Hello and welcome to Coffee Table Physics. I'm Riley.
And I'm Jonathan. The reason you're probably here is because just like us, you wondered why the things float.
Well, you may have heard of a chap named Archimedes. One day he got in the bath and noticed that the water level of the bath rose, and at that moment shouted, "Eureka!" This was the eureka moment that coined the phrase eureka moment, as Archimedes realised that when an object is submerged in water, the volume of water that it pushes out of the way is equal to the volume of the submerged part of the object, in this case, his body. We say that the volume of water is displaced by the object.
This led to him stating that any object fully or partially submerged in a stationary fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. Funnily enough, this is known as Archimedes Principle. In order for an object to float, Newton's first law states that the forces must be balanced, and so this buoyancy force must equal the weight of the object.
However, by Archimedes' principle, the buoyancy force is equal to the weight of the fluid displaced. Therefore, the weight of the fluid displaced must equal the weight of the object. This is what causes something to float, and so is known as the principle of flotation.
Density is the amount of mass per unit volume. In other words, how much stuff is squashed into a given space. If an object is less dense than the fluid, an amount of fluid with the same weight as the object will have a lower volume.
When you put the object into the fluid, in order for the buoyancy force to balance its weight, it must displace a volume of fluid whose weight is equal to its own weight. Thus, an object with a lower density will displace a volume of water less than its own volume. Therefore, part of the object is submerged to fill the volume of displaced fluid, and the rest of the object remains out of the fluid, and so the object floats.
For example, if we drop a ball with half the density of water into a glass of water, it must displace its weight in water. Hence, the volume displaced will be half the volume of the ball. As a result, only half the ball will be submerged, so the ball floats. If we could increase the density of the ball to be just less than that of water, then the ball would float with only the very top of the ball breaking through the surface.
Now, if we increase the density so that it is more dense than water, the object would become completely submerged and would no longer float. Now the object will displace the volume of water equal to its own volume. This means that a buoyancy force equal to the weight of the water displaced will act on the object.
But since the object is more dense, the volume of water will weigh less than the object, and so the buoyancy force will be less than the object's weight. Therefore, by Newton's first law, since the downwards force of weight is greater than the upwards buoyancy force, there will be a net force downwards. Hence, the object will be pushed down through the water and it will sink.
In summary, if the object has a density less than the density of the fluid, it will float. If the object has a greater density, then it will sink. So why do these ice cubes float? If you put cubes of solid gold in a cup of liquid gold, they would sink. Unfortunately, for financial reasons, I can't really demonstrate this.
This is the same for most substances. In a liquid, the molecules are moving around each other. Now, if we lower the temperature, we reduce the amount of kinetic energy, meaning each of the molecules move around less and so take up less space. This is why solids are usually more dense than liquids, as the molecules merely vibrate around a fixed position, and so the molecules are held more compactly in a regular structure. Since the solid is more dense than the liquid, the solid sinks. But solid water, ice, floats in liquid water. Therefore, ice must be less dense than liquid water, right?
Right. Every water molecule is made of 2 hydrogen atoms bonded to 1 oxygen atom. This means water has a special kind of interaction that most substances don't have, called a hydrogen bond. This means that molecules bond by sharing a hydrogen atom rather than sharing a pair of electrons. In liquid water, hydrogen atoms are constantly breaking and reforming. But as we start freezing the water, hydrogen bonds form much more than they break.
As a result, in ice, the molecules are held in a hexagonal structure, creating space between the molecules. This means there are fewer molecules in a given volume, and so ice has a much lower density than liquid water. If an object is less dense than the fluid it's in, it will float. So ice floats on water.
Similarly, people float on water. Now, around 70% of your body is made of water, and therefore the average density of a human is close to that of water. Fat has a lower density than water, whereas muscle has a higher density. In the end, the densities of the different materials in our bodies average to give a density less than water, and so we float.
However, you may have noticed that it's easier to float in the sea than it is in a swimming pool. This is due to the high amount of salt dissolved in seawater, which increases its density. This reduces the volume of water which has to be displaced in order to balance your weight. Hence, less of your body is submerged. If you ever go to the Red Sea, be sure to take a book to read whilst floating, as almost all of your body remains out of the water. This is due to it having a much higher salt content than most seawater.
And so we reach the end. Now next time you're chilling in the sea, you'll know why you're floating.
Thanks for joining us. If you have any thoughts on the video, feel free to leave them in the comments box.
Plus, tell us if there's something about this wonderful world around us that you think, I want to know what's going on here. We would love to help.
See you here next week.
Same time, same place.
Cheerio!